Hi everybody, I'm Maria.
And I'm Pamphile.
And together we are going to tell you how to read SimDec. SimDec, or simulation decomposition, is based on a histogram.
Let's take, for example, pandas.
Pandas?
Yeah. And we want to measure the speed of pandas. And so we take 10 individuals and we record the speed of these 10 individuals.
And so then we have an output array of 10 different numbers.
Yes, precisely. And taking this data, we want to put that in a graph. On the x-axis, we are going to have the speed of the panda. And on the y-axis, we are going to have the counts. So how many individuals fit into some categories. And so here we have a few categories, a few bins or intervals. And every individual, every panda that we have, we want to place this individual into the graph.
Where does the first panda go, which runs 1 kilometer per hour?
Yeah, so the 1 kilometer per hour, you see here, there's a bin, and we can just place this panda here, and we reproduce that for all the pandas.
Okay, all other pandas go into their consecutive bins.
Yes.
Okay, and then we have a histogram.
Exactly.
And the count here actually counts our observations.
Yeah.
Okay, and then if we divide those values by the total number of observations, then we'll have a share of samples or probabilities.
Yeah, something like that.
Okay. And from a histogram like that, we can tell the minimum, the maximum, the shape of the distribution, but not much more. So that's why we want to apply SimDec to see how the output is affected by different inputs. And there could be different degrees of this effect visible on SimDec. For example, there could be no effect.
What do you mean, no effect?
Like, for example, if we take panda speed and model them as a function of food intake, so no matter how much we feed the panda, they're still slow. Yeah. And then we'll have a horizontal boundary on the SimDec graph, meaning that both states or scenarios overlap, and no matter in which state you are, high feed or low feed, you would be in the same range of the outputs, which is speed.
Yeah. So what about we have the case where factors influence more the output? So we take squirrels?
Squirrels who are eating nuts, and then nuts are very energetic, and the more nuts they eat, the faster they actually become. Why not?
Maybe.
And then our boundary here would be more of a diagonal, which implies that there is more observations that are faster when more nuts are eaten, consumed.
Okay.
But there could be also a different type of situation where input affects ultimately the output, dividing it into two distinct ranges.
You mean like lions?
Lions?
Yeah, lions. If a lion is hungry, he's going to run faster to get food and to eat. But once the lion has eaten, then the lion maybe is going to just sleep.
Yeah, and even if not sleeping, it's going to be lazy and moving really, really slow, right? This is how you can analyze the effect of a single input variable on the output and judge its importance in the model.
What do you mean single input? Do you mean that we can also analyze multiple inputs?
Of course, that's the value of SimDec. We can analyze how multiple inputs jointly or interactively affecting the output, and there could be different shapes of those interactions.
So if we take again the example of the squirrel, squirrel's speed was affected by the amount of nut he was eating, and if there is a lion, then the squirrel is going to be even going faster, maybe
That's true. The presence and actually proximity of a predator would reinforce the amount of food the squirrel consumed and make it run even faster. Why not? So this kind of reinforcement, which looks like that, it's a classical picture of a multiplicative interaction in a model. Yes, but there could be even other types. For example, the same squirrel, if it eats good nuts, then it runs faster, but if the nuts are wrong or bad, then it gets poisoned and it slows her down. And that's how one input variable switches the direction of the effect on the output depending on the state of another variable.
So we can measure bifurcation in any models? Then.
Yes.
Okay.
What else could that be?
If you have on-offs, maybe parameters?
True, for example, the same line. So it moves fast when it wants to eat, and it moves slow when it doesn't want to eat anymore. So the food affects the speed of the line, but if there is, for example, a pretty lady lion somewhere nearby, then the food factor is not influential anymore, and the lion would be totally captivated by the lady.
I see.
Yes, and this is also a common situation for example, models that have different scenarios or some binary variables and have some structural differences in the computational logic. Yes, and in general, this is how you can analyze the behavior of the model with SimDec and judge different behavior, judge how different input variables affect jointly the output, no matter what the model is, not necessarily about the speed of animals. It can be
a fluid dynamic simulation.
Yes, or profitability of investment, or engineering model, or carbon footprint, or environmental model, anything. Anything.
Oh, before we go, all the characters in this movie were fictionals.
Oh, and no animal was harmed.